bam, it's true. So we just learned the basic rules of differentiation. Why are they called basic rules? Because, well, they're basic, and they're not always enough. So we're going to start learning other techniques, other rules that we need to differentiate equations. One of them, the one in this video, is going to be called is the product rule. When you want to find the derivative with respect to x of two functions multiplied together, it is equal to the first function, or factor since these are multiplied together, times the derivative of the second function plus the derivative of the first function, or factor, times the second factor, or function. So we're going to have 5 examples, and you'll see that it can be a little bit tedious. So we are going to do this example, this first one, only twice. I don't think you can do the other ones in multiple ways. This particular first example, we can either use the product rule or we can use the basic rules of differentiation. Just to make sure that we understand how this works, we're going to use the product rule first, and then I'm going to adjust this a little bit and show you that just because the problem looks like it requires the product rule, you may be able to manipulate a little bit and just use one of the basic rules, which would make it quicker. So we have y equals 2x squared minus 5 times negative 3x cubed plus x. So the first factor times the derivative of the second, so y prime, or the derivative of y, is going to be equal to 2x squared minus 5 times the derivative with respect to x of negative 3x cubed plus x, plus the derivative of the first factor, which is here, so derivative with respect to x of 2x squared minus 5 times the second factor, which is going to be negative 3x cubed plus x. So we have, well, I'm just going to copy this down again, 2x squared minus 5. The derivative with respect to x with this factor is going to be negative 3 times 3, which is negative 9. And x, we need to reduce that exponent by 1, so that's going to be squared. And then we have plus the derivative of x with respect to x, that's just going to be 1. Plus the derivative of 2x squared minus 5 is going to be 4x to the first. The derivative of a constant is 0, so we don't need to write that because we're just adding by 0, and I don't need to write an exponent of 1. And times the second factor, so negative 3x cubed plus x. So now all I have to do is, well, that's all I have to do. I've got to FOIL all this out, or distribute all this out, and simplify until I get my answer. So we have negative 2x squared times negative 9x squared is negative 18x squared, and then positive 2, that would be to the fourth, positive 2x squared, and then negative 5 and negative 9 is positive 45x squared minus 5. Then we're also going to distribute this 4x, and we get plus 4 times negative 3 is negative, well, let's carry the whole. Let's take the whole positive 4x and multiply it through. So positive 4 and negative 3 is negative 12x to the fourth, and positive 4 and positive 1 is plus 4x squared. Now we have to add like terms. So we have negative 18 and negative 12 make negative 30. We have 2 and 45 make 47, and 47 and 4 make 51, so plus 51x squared minus 5. Let me just make sure I didn't make some small mistake here. Good. Alright, so that is the derivative of y using the product rule. Now, I could have just distributed this together in the first place and used the basic rules of differentiation instead of this process, which is a little bit tedious. Yeah, okay, so we have y is equal to, let's see, 2x squared times negative 3x to the third is negative 6x to the fifth, and then 2x squared plus or times x is positive 2x to the third. And then we have negative 5 and negative 3 is positive 15 x to the third power. And then we have negative 5 and positive x, which is negative 5x. Okay, well, now we have y is equal to negative 6x to the fifth. 2 and 15 make 17, so plus 17x to the third minus 5x. And now I just have a basic polynomial that is very easy to find the derivative. Y prime, or the derivative of y, is equal to, and it's all with respect to x, is going to be 5 times negative 6 is negative 30x to the fourth. 3 times 17 is 51, so plus 51x squared minus 5. And you see I got the exact same answer I did in my first method of doing this problem, and got it with a decent amount less work. So if you can maybe clean up your original problem before immediately thinking I got to apply the product rule, you might save yourself a little bit of time. The next 4 examples, though, I don't believe they are going to be, you're going to have the possibility of doing this. And I'm just saying that because I don't remember exactly what I wrote down for examples. Yes, okay, so we are going to have to use the product rule for the remaining, well, I said 4 examples. We have remaining 3 examples. All right, bam! Our next 2 examples, we have f of x is equal to the square root of x to the third power times cosine of x, and this whatever over here. So we are going to deal with this first. We cannot or do not prefer to work with radical notation, so we're going to change the square root of x to the third power into, let's see, your power and root. This is square root, so that's going to be x to the 3/2 power, and apply the product rule. So f prime of x, or the derivative of x, is equal to the first factor times the derivative of the second, so it's going to be x to the 3/2 power times the derivative with respect to x of the cosine of x plus the derivative of the first factor, so the derivative with respect to x of x to the 3/2 power times the cosine of x, with, of course, no derivative on it. That is going to become x to the 3/2 power. The derivative of the cosine of x, remember, is negative sine x. I'm going to let that negative float out front. Sine x plus the derivative of x to the 3/2 power. We're going to take that exponent, move it out front, have it be 3 over 2. Reduce that exponent by 1. 3 over 2 minus 1 is 1 over 2 cosine of x. That's it. Only thing, if you wanted to write this so that you were back in radical notation, you could, but that's perfectly acceptable and correct for the derivative of f of x. Now, moving on to this example over here. Again, we have, now inside this second factor we have 2 terms, so we're going to kind of be doing the sum rule and the product rule at the same time, but it is the cosine times this second factor. So f prime, it's a little division line there, f prime of x is equal to the cosine of x times the derivative with respect to x of sine x plus cosine x. And now I'm here, so plus the derivative with respect to x of the first factor, cosine of x, times, and I'm starting to run out of room, sine x plus cosine x. Thought I left myself plenty of room there. So cosine, the derivative of the sine of x plus cosine of x. Well, this is 2 terms in here, so we learn with the sum rule that we just take the derivative of each term separately. And the derivative of sine is cosine, and the derivative of cosine is negative sine. So instead of plus, we have minus sine x. Again, this is plus, but I don't want to write that yet because the derivative of cosine is, again, negative sine. Let me just make sure I'm not being out of my head here. Minus sine x. times sine x plus cosine x. All right, well, let's see here. Distribute through the parentheses, and we get cosine times cosine is cosine squared minus sine cosine, sine x, cosine x, minus sine squared x, and again, we have minus sine x, cosine x. We have like terms here. We have two sine x, cosine x terms. So we have, I'm going to bring the sine squared over. So we have cosine squared x minus sine squared x. And then negative 1 and negative 1 makes negative 2 sine x cosine x. And that is the derivative of x. That'd be perfectly fine. I'd be happy with that. You could get super fancy because this is the double angle for cosine. So that is the cosine of 2x. And this is a double angle identity. The 2 sine x cosine is equal to the sine of 2x. But that's perfectly acceptable and correct for the derivative of our original function. So let's do one more example and call it a day, shall we? Last example. We have f of x is equal to negative 3x sine of x plus 4 tangent of x. I chose this example because in one term we have to use the product rule. That we basically have here negative 3x times the sine of x, and over here we have 4 tangent of x. So, you know, this is some stuff multiplied together. If I group this up, we have 2 factors multiplied together. Here we have that as well, but with the tangent of x, we have a constant. So we're going to use the constant rule for the second part of this. You could use the product rule, but you're just going to write a bunch of stuff and you're going to get the same answer with a lot more work. So we're going to use the constant rule for the second term, and you know, we can't use, that's not a constant, so we're going to have to use the product rule for the first one. So f prime of x, or the derivative of x, f of x, is equal to negative 3x times the derivative with respect to x of the sine of x plus the derivative, using the product rule here, derivative with respect to x of negative 3x sine x plus the derivative with respect to x of 4 tangent of x. Now, when we did the constant rule, I showed you how you could take these constants of negative 3 here with this one and the 4 and move them out front. I'm going to save myself the writing and not do that again. We have negative 3x times the derivative of the sine of x is cosine x plus the derivative of 3x is simply equal to, it's negative 3x to the first. So bring down that 1, multiply by negative 3, get negative 3. The exponent goes down to 0, so the x just becomes 1. X is 0 powers 1. So the derivative with respect to x of negative 3x is negative 3 times the sine of x. This 4 is going to come out, and we get plus 4. And the derivative with respect to x of tangent of x is equal to secant squared x. And that's pretty much it. I'll just, I guess I could, you know, we don't like to, why write plus negative? So we can take that and just write minus, big old minus sign, 3 sine of x. And that's it. That's the answer. With your trig functions, you might get what you feel is a good final answer and look in the back of the book and, well, not see your answer. These parentheses aren't doing anything either because there's just one term inside. So you might get what you think is a good final answer, and it is. It's correct. This is f prime of x, or the derivative of x. And then you might go in the back of the book and realize, well, where'd the secant go? You know, secant squared x is the same as 1 over cosine squared x. So I could make this 4 over cosine squared x and then find common denominators and all that stuff. So you might do your derivative problems correctly that have trig functions, but then not see the exact form of your answer in the back of the book, and it just makes it difficult to make sure that you actually have a correct answer. So this is good. If you go in the back of the book and, or whatever problem you're working on and that's not what's back there, maybe just take what you have as an answer and try and manipulate it to appear to be the same as what's in the back of the book. It doesn't necessarily mean you have done it wrong. I'm Mr. Taru. Bye! Go do your homework.